Hey guys, I hope everyone had a good Easter weekend. Um, while I'm drinking my mug, I want to show you how cool it is. My sister-in-law gave it to me. And it's just perfect, especially now during this time. But so I'm recording this in my house, and we'll see if any of my children come in screaming or they're fighting in the few minutes I'm going to record this. So anyway, so I know right now the high school's having like a makeup week because it's midterm, but we just can't do that. We gotta start reviewing. And the other reason why we're not gonna not do anything this week is because I already feel like I've been going a lot slower than usual, anyways, by doing just like Monday and Wednesday type things. So, anyway, some of you will probably be mad at me for that, but um, we need to review like how you know when to use what type of test. Because now we've learned all of the 5 tests. Okay. So so the 5 tests that we learned in 1040, we have, well, actually, I'll probably write them below this, but anyway, hopefully you guys all got this flow chart. I put it in your folders either last week or the week before. And hopefully this will just help you organize your information. And no, you can't use that on the final, but this should be a good steady help. Okay. So, first of all, when you look at a problem, you want to ask yourself, is this quantitative data or is it qualitative? So, can we, describe this with numbers or are they into categories, right? Because that will help you first sort like what type of test. So if it's qualitative and there's just one sample, then you will probably just have a 0, 1 box model that you make, and it will be the z-test because there's just one sample. And go ahead and cross this off because we're not going to use EV sum and SE sum. We're just going to do the percentages. If it's qualitative, it can also be into 2 sample or 2 groups, and that's where we do the 2 sample Z. So this is 2 sample Z. Sorry, that's a Z. Z test. Okay. So that's where you find the observed difference minus expected difference divided by SE difference. And remember, this is the SE difference. It's really the Pythagorean theorem. And then you just find, you either use EV average and SE average or EV percent and SE percent. And so that's probably, I wouldn't say the most difficult, but it just has more steps than all the other tests. So which makes that one by far the least favorite. Anyway, but it's really, it's just more work and more steps, which therefore you probably might make more mistakes, but you shouldn't because you have all the formulas and everything. So, okay, so that's with qualitative data. If you have quantitative, then you need to either look at, well, do I have 1 sample or do I have 2 samples? Because if it's 2 samples, then we go back to this 2 sample z-test. If it's 1 sample, then we need to look at, well, what is the sample size, right? If the sample size hits our magic number that we like, which is 30 or higher, then we can use the normal curve, and it's a 1 sample z-test, right? And we're going to cross off use EV sum and SE sum because we're not ever going to use EV sum and SE sum for hypothesis tests because that's just, yeah, anyway. Okay, so we have, if it's greater than 30, we have a 1 sample Z. If it's less than 30, remember that's the t-test where, where we learned about the Guinness Brewery. Remember that video? Um, where, and the T curve, because I'm actually teaching my other stats class about the t-test today. So I have this pulled up. So just remember the T curve has more area in the tails. So that changes the SD. So it's still the T. Instead of the Z score, you do the T observed. It's still the exact same thing, right? Cross off this EV so I see some crap. Just remember you use SD plus, or if you're putting them in a calculator, remember it's S sub X, like SX in the calculator. And really that's, oh, that, and then you, instead of norm CDF, you do TCDF, which is, I can't even remember the shortcut, but I know I have that shortcut on the formula sheet that you can use on the final. I do have whatever TCDF is. Anyway, so those are the two things that you need to change if the sample is less than 30. So if it's less than 30, it's going to be a t-test. And we use the SD plus or the SX, and then we go TCDF instead of norm CDF. All right. And then the last one, which is probably your guys' favorite ones, is the chi-squared, and not chi. It is not chi. Some of you said that in your videos, and I wanted to deduct points, but I didn't. I'm doing a video, bud. It's by the fridge.
Okay. Did you eat a candy bar?
Anyway.
I was.
Okay.
I was.
Told you it would be impossible. Okay, so your favorite one that you'll probably like is 1 sample qualitative data, which is the chi-squared, like I mentioned. And so you just need to figure out, is it a goodness of fit test where they're just saying, hey, does this qualitative data fit this model? Okay. So a lot of the times we've used M&Ms, but you'll have obviously other examples where you just have one thing, but it's split up different ways, whether it's like, is a 6-sided die fair? And if you test that, that's just one thing, right? If it's multiple things, then it's going to be the independence, right? So if you're looking at pace, and this would be the easiest one to figure out. Basically, are these two variables, do they depend on one another, or do they not depend on one another? And that's how you know it'd be independence. Goodness of fit is, does it fit this model, or does it fit it? Anyway, so hopefully those are easy to figure out. With the goodness of fit, Hudson's yelling. Anyway, with the goodness of fit, you do need to find your observed and expected counts. And remember, that's when you put them in a list. And you actually have to figure out what the expected counts are. So whether that's times by the percentage or they're all the same, whatever it is. But that's where you make the two lists. Independence is where you do a table. Hopefully you guys hear Hudson yelling. I like to call him the Hulk because he has a temper. Anyway, so independence is the table. Not table. What am I thinking? Oh, it has a table, but then you store it as a matrix. Oh my gosh. Anyway, and then the goodness of fit is just observed and expected. So, but those you guys probably remember the best because they're the most recent and they're pretty easy. So, anyway, so what I'd like you to do today, or just by Wednesday, I guess, is just do this. let me show you what kind of test. So basically, you'll just have a question, you'll read the problem, and then by looking at your flow chart, you'll figure out, okay, what kind of test is this? So the 5 are the 1 sample z-test, and then we have the 2 sample z-test, and then we have the t-test, which is always just 1 sample right now, and then we have the chi-squared. So chi-squared goodness of fit, and then we have chi-squared independence. So these are the 5 tests that you have to figure out. How do you know which one to use? And then once you know which one, can you actually do the test? So anyway, so the assignment is just what kind of test. And then Wednesday we'll actually do the actual tests. So hopefully, oh no, I better just end right here. Hudson, would you like to say hi?
No.
Oh, geez. Okay. Well, I'll be available if you guys have any questions. Have a lovely day. I'm going to try to do the same.